Hi everyone, welcome to season 2, or we're gonna call it the NAV Panel project. So as promised, we're going to start building the NAV panel, and then the next one will be the COM panel, and then the ADF panel. For the NAV panel, I decided to print everything on the 3D printer. So I've designed the back plate of the panel. It's going the panel. It's going to be this back plate where everything attaches here, and then there will be a front plate. So I've decided and 3D printed the plate. It looks quite good and functional. Also, we're going to need, of course, the Arduino. Got a new one since the other one is dedicated to the upper panel. Besides the 3D printing, we need some stuff. We need here, I got some switches. Okay, these switches are very simple switches, only click switches, very small. We need 2 of these. We need 2 rotary encoders. This is not rotary switch, this is rotary encoders. If you look in here, it's got 3 pins on one side, being one the ground and the other ones are the left and right. So it will take 2 pins on the Arduino plus ground. And then on the other side, it's got 2 pins. These ones is because they actually have a push button, which I'm not going to use on this project. So we need 2 of these because the NAV panel is a double rotary encoder, and then I'll show you next how we're going to assemble these. We also need these ones. Now this is the 7 segments. I've got them already with the MAX 7129 chip. So they can basically, they will need 5 pins, being one the power and one the ground, and the other 3 pins on the Arduino itself. Which means with this MAX 7219, we can run 8 of these. So what's going to happen is that instead of connecting each one and just wasting a lot of space in the Arduino, I will just connect 5 cables from here to the Arduino, and then I will series the other 7 segments that I'll need for the COM panel, the ADF panel, and for the ATC panel. It's going to be enough. So here we need 2 of these. As you can see, these ones come with the pins. They have these L-shaped ones, and they have some straight ones. Usually, when you see people doing this stuff, they just mount it from the front. In here, they put it in the slots, and you need to solder them, and they run like this. But because of my build, I'm just going to do it the other way around. I'm just going to insert them from the back, solder them in here, because they will go and they will be placed inside here, and they will be fixed by hot glue. Okay, and then it will take the upper panel on top of these, so they will be somewhat fixed like this. As far as the switches, I made some slots. They will just fit properly. Okay, they just fit in there, just drop a little bit of glue and they will be fixed. The other switch is going to go on that place, and the double rotary, it's going to be here on this placement. I will show you then how to mount this. Okay, so now going on soldering, I will solder everything on the 7 segment displays, and then I will run the wires, and then I'll run the next step. I'll show you how to mount the double rotary encoder there. Okay, so I'll be right back. So the soldering, it's all done on the rotary encoders. Now the question is how you make one double encoder out of two normal encoders. And for this, there was a solution that I found on Thingiverse from a guy called Flight Sim Maker, and which is this box here, which I've changed to my needs. I kind of made it a little bit bigger, some of the parts, because my encoders, the shaft is a little bit bigger than what the guy original made the design for. And this, it's magical because it turns the two encoders into one, and it's very easy to assemble. First, you're just going to assemble the encoders on this cap. So after attaching, you attach the big slot in there, the shaft, the big shaft. Then you have a small shaft that you fit on this one. Then you have this one that you're going to fit, and these two wheels are connecting together. So how this works is this is going to extrude. This is going to be outside of the box itself. And what happens is the larger button only turns this knob here, the rotary here, and if you rotate the small shaft, it only rotates the other shaft there. So then you just put the box together, goes in quite easily. This is going to be mounted on the back part of the back plate. I've made a slot here so I can insert and hot glue the rotary switch there, and there you go. Now that this is done with double rotary encoders, time to grab our back panel again and fix the two small switches that we are going to use for switching the frequency and the test button. Okay, the switches are super glued in here. It went fine. We're just going to put this one aside and we're going to go back in our 7 segments. So we need to connect these 7 segments to the Arduino, and then I'm going to loop the 7 segments together, because since this got the max chip, you can connect 8 of these in series, and that will only take 5 slots on the Arduino, so it's quite practical. Okay, so we have the plug put in to connect the 7 segment to the Arduino. It will be easier to connect with this plug. Now it's time to wire the switches. Now it's time to install the 7 segments. So they are going to be installed like this in here. And as you can see, due to my constraint of space, on the outside, that's where I soldered the pins, the straight pins. And on the inside, the L1s. If you notice here, when I put the 7 segments here, I have a very close distance between these two terminals. So instead of soldering and making a small wire go from place to place, I think it would be easier if I go back and use the female plugs that I have for these kind of plugs. If I just put it on one side and connect it to the other, this way I don't need to do any soldering and they would fit perfectly. So that's what I'm going to do now. connect all these pins, and then we are basically ready after hot gluing the double rotary, which is here, which will be hot glued in this position. Okay, the panel is ready to be installed and to be tested. So here I just hot glued the case for the dual rotary. It's perfectly there. Everything, it's mechanically operational. I soldered, if you see here, I put a bit of solder to connect all these pins. As of safety, I will just put some hot glue in here because it isolates the contacts. And this is going to be mounted back here. As you can see, it goes in, and it's got to be hot glued also to the back plate and stays right on the face. So how do I know it stays right on the face? I got the face plate, okay, 3D printed. How did I get the lettering in? It's engraved on the gray plate, and then I print the letters in white, and I just punch them in. Then I sanded a little bit on top, so it looks okay. So now we're just going to join these two plates together. Okay, I will put some screws, and then I insert the 7 segments back here, and they will be right against these plates. So that's the plate, the place they should be. Okay, so that's what I'm going to do now. So the panel is ready. Hot glued the 7 segments, super glued the box there with the double encoders. Now for the final touches, I print some knobs for the test button, which I will super glue over there. And I printed the transfer button. Again, the same technique. I printed the button with the engraving, and then on white PLA I printed the arrows and I just stuck them there. So these are going to go there, super glue there. It's gonna look nice for sure. And for the final, very final touches, the buttons also downloaded from Thingiverse and adapted to my own needs, but they will look awesomely good in here. Let's check, and there we go. Functioning rotary knobs. So we're gonna finish this. I'm going to wire it up to the Arduino and put it on the simulator, and then I'll let you guys have a look.